Good morning, students. This video is going to show you some of the techniques we use when solving a mathematical problem in AP Physics. This problem is a pretty typical kind of one-dimensional motion problem from kinematics. This one comes from My Open Math for Physics C, University Physics. So it's a college level problem. First thing I would recommend you do when you read the problem is to draw a picture, or if there's a picture given, to label the picture with anything that's described in the problem statement. Let's read the problem statement and then we'll draw a picture since there isn't one given. You are standing right at the edge of an overhanging cliff that is 18 meters above the ground. You launch a super ball straight up at 12 meters a second. So an overhanging cliff looks something like this, say. And there's a stick person standing right at the edge, say holding the ball over the cliff, and they're going to toss it up. I suspect that that's what it looks like because I've already read these little subparts of the question. How long will it take to reach its highest point? How high does it go above the launch point? How long does it take to hit the ground? With what speed does it hit the ground? And then a question about the acceleration of the ball while it's in contact with the ground. So I've already read all those, but you would want to read all those and make sure, or at least the first one, and make sure that your drawing reflects what they're going to ask. So they said this is 18 meters high. So I'm going to label that 18 meters. And they said that the initial velocity of the ball is 12 meters a second straight up. And I'll label that V0. Now, next thing I would recommend doing is to identify things that you know about the situation just because you're a physics student. So one thing that you know when you see a problem like this is that the vertical acceleration is equal to the gravitational freefall acceleration, or the freefall acceleration due to gravitational pull, and that is negative 9.8 meters a second squared, which is approximately negative 10 meters a second squared. Okay, so then we also know that the ball will stop at the top of its path. So I'm going to say that Vy, velocity at the peak, equals 0. It's going to stop because it has to go up and fall back down. A third thing we know is that at cliff level, on the way down, V equals, I'll call that Vy, equals negative 12 meters a second, because the ball will have a symmetrical graph on the position time graph. So for instance, I can sketch that position time graph. Oh, my bad. I just realized, depends on what I call zero position, how this position time graph is going to look. So let's think about that for a second. Let's call this initial position, we're going to say, I'm just going to assume that the ball is launched from 18 meters above the ground. They don't tell you the height of the person, so there's no other number to work with. And if we're going to do a mathematical calculation, we're just going to assume that the ball is launched straight from the edge of the cliff. So maybe I should have drawn my stick man leaning over so that their hand is launching the ball exactly at the height of the cliff. But we've got to assume that in this case. Maybe it's a little bit of a sloppy problem writing, you could say. Anyway, so I'm going to say that initial position, I have to decide if I want to call that 18 or 0. If I call it 0, then the final position is going to be negative 18. Let's do that just for the sake of argument. You could also call it positive 18. Let's do that. Let's do that. Y initial equals 18 meters a second. That means that Y final equals 0. And that's at ground level. Okay, so now I think I've listed a bunch of things that I know. I could sketch a position time graph, which I started to do, but it was hard to do before I'd figured out what I wanted to call initial position. So I'm going to do that now, and it doesn't have to be quantitatively accurate, but it should be qualitatively accurate. So this is 18, and the ball will do this. What I'm saying is, when it gets here, the slope of the tangent line at this point, which is at 18 meters again, will be equivalent in slope, in magnitude, to the initial slope. So this speed will be 12 meters a second, and the velocity will be negative 12 meters a second. And I could also sketch a velocity time graph. I start at 12, and I can see that by looking at the position time graph down here, like this is going to be steeper down here where the super ball hits the ground. So this must go below 0 farther than it goes up. Okay, so let's start doing some calculations. I did a whole lot of thinking. That's usually a good thing to do. Start with a picture or label the picture that's given. List out what you know or what you can deduce. Sketch some graphs if possible, and then try to solve the problem at this point. Now, the first thing it says is, how long will it take to reach the highest point? Well, I figured out that the peak velocity will be 0. So I can write an equation of this form to solve that. So this is what's on the AP equation sheet. Oops, I mixed my x and y. Bad mistake. Never do that. In a scalar equation, we're just going to have only x's across there, or only y's. Okay, so I'm going to rewrite this. So this is my basic equation. I'm going to rewrite it with y's because it's a vertical situation and kind of confusing to label things that are vertical with x's. And then I'm going to remember that I know what gravitational acceleration is. I can use negative 10 or negative 9.8. Let's just use negative 10 meters a second squared. And I know the initial velocity is 12 meters a second. I'll give that a little positive to emphasize that. Okay, so then we can say at the highest point, 0 equals 12 meters a second minus 10 meters a second squared times the time interval t. Then solving, t equals 10/12 seconds. Well, let me show you how you get those units in case you're not clear on that. That's meters a second over meters a second squared, and that would be, or I'll pull that out over here, that will be meters a second canceling. One time, leaving 1 over 1 over 1 over seconds. When I simplify that, that's just seconds. Okay, so anyway, that's just an aside, but the answer is 10/12 meters a second squared. In AP Physics, when it's a numerical problem, you should give a decimal answer with approximately correct significant figures. College Board is not real picky about the significant figures. As long as you got 2 or 3, I don't think you'll stand a chance of losing credit. So that is t equals 0.83 repeating. 3 digits are given, so I will give 3 in the problem. I will give 3 digits in my answer, and that's what I'd enter into my open math. So that's part A. Next question is, how high does it go above the launch point? I'm running out of space here, but you're just going to have to remember the first part of the problem. I would use a version of this equation, I think. This is the basic equation on the AP equation table. Again, I'm going to rewrite it into a slightly more specific equation for this particular problem. I'm going to go ahead and put a negative sign here, minus 5 meters a second. Oh, I won't do that. I didn't put any numbers in yet. Minus 1/2 magnitude of g t squared. So now that's written for the vertical. I can add numbers. I was asked how high will it go, so I'm looking for final position. Initial position is 18 meters, so I can say that y equals 18 plus 12 meters a second times 0.833 seconds minus, now I'm going to go ahead and say that 1/2 times 10 is -5, 1/2 times -10 is -5, times 0.833 seconds squared. So all the numbers are given. This is a relatively easy problem. When that's the case, I didn't have to do any weird algebra. And I'm just plugging in my calculator to see what I get. Well, I just looked at my expression in my calculator, and I did not type the right thing in. So give me a second. That looks correct. I hit enter, and I get 36.5 meters a second. Or pardon me, meters. Okay, so what was I asked for? I was asked for how high does it go above the launch point. That's not what I found, because this is the initial position, 18 meters. I found the total height above the ground. So this is something to be careful with. Think about what your answer means. And I'm just going to subtract. So h above, I'm going to call this a different variable because it's not the y position. It's the height above the launch point. I'm going to call it h, and that'll be 36.5 meters minus 18 meters, the initial position. So that'll be 18.5 meters. That should be correct. Let's see, what else have we got? How long does it take to hit the ground? Okay, so how do we want to solve how long does it take to hit the ground?